All right, guys, so this is a lesson, 515 notes for modeling with polynomials and doing a cubic regression, okay? So similar to what we did for quadratic regression, we're going to go to Desmos, and we're going to plug in this table. All right, you're going to go to the plus right here, plug in the table. You're going to plug in the numbers. These are hours by time, so I'm not going to do 1 point or anything. I'm just going to do 1.0, 2.0, 3.0, 4.0, 5.0, 6.0, 7.0. Okay. Now right here, you're going to put exactly what it says. It says 7 hours, so 7.0, 10.8, 14.5, 21.1, 23.9, 19.0, and 10.0. Okay? So this is your table, all right? Now, for our cubic regression, all right, it says predict the type of polynomial that the best models it. This is a cubic, okay? And then using Desmos create a scalar plot of a data. So we are going to use a formula, just like we had for quadratic. It's going to be y1, okay, wiggle, which is the left top corner of your keyboard. Now, since it's a cube, it's going to be ax1 cube plus bx1 square plus cx1 to a first power plus d. So this is a cubic regression formula, okay? So we are going to put that equation into Desmos, exactly that equation. This is a cubic equation. So we're going to do y1 wiggle ax cubed 1 plus bx squared 1 plus cx1 to a first power 1 plus d. Okay, so that's the formula. And again, using the same plot, just emphasizing that you do x1 and y1 because you're referring to your table. We get these values right here. So I'm going to write them down right here. Okay, so my a was equal, and I'm going to round it up to 1,000. So 0.406. My b had equaled 3.502. My c equaled negative 4.47. And my d equaled 8.443. Now, when it's asking us to write an equation together, determine the regression equation, we're going to plug in these values right here for a, b, c, and d. So a, b, c, and d. So my a is negative 0.406 of x cubed. Now plus 2 x squared. Now minus 4.47 x, and then plus my d, which is 8.443. So this is my regression equation, okay? Now, the next question talks about sketch the regression equation, and it says, use the regression equation to make the following prediction. Predict the number of vehicles that enters or exits downtown during the hours starting at noon. So remember, our time started at 1 and it was at 7, so at noon, okay, it would be at 0. Okay, so at noon, which is at 00 hour, it would be at 0 hour. Okay, at noon, it would be at 0 hour. So we are going to plug in x equals 0. Okay, so in the same equation, negative 0.406. Now times, instead of the x, we're going to put 0 cubed. Okay, plus 3.502. Now it was 0 squared. Okay, minus 4.47 times 0 plus 8.443. So logically, this is going to be 0. This is going to be 0. So my answer is going to be 8.443. Now B, it says predict the number of vehicles to enter exit downtown during the hour that starts at 9. So again, x will equal now 9, okay? So we're going to plug in 9. So again, 0.406. Now 9, which we're going to cube, okay? And then we're going to do 3.502 now. We're going to cube and then square the 9. And then minus 4.47 10 times the 9 plus 8.443. Now again, if you put it all in the calculator, just don't forget to square it, cube it, and use these instead of the x's, because again, the formula was right here. We're going to plug it in instead of the x. This is what we're doing. We plug it in instead of the x. So all these values we're going to plug in instead of the x. When you put it all in the calculator, you should get negative 44 vehicles. Okay. All right. So vehicles. So no vehicles on the weekdays starting at 9 p.m. Okay. So negative would mean no vehicles on the weekdays starting. And here we would have 8 vehicles at noon. Okay. So that's all you need to know. You need to know how to do the cubic regression for the formula right here for you. And you need to know how to plug it into the calculator and then how to plug in instead of the x's, the values that you asked about to calculate.